we need to finish up lesson 6-2 and our multiplying and dividing. I would encourage you to still have a blue paper by your side today. And I would also encourage you to have a calculator by your side still. Okay? Anyone else not get a blue paper yesterday? Or anyone already misplaced their blue paper and need another one? We're good? Okay. So, we ended yesterday on dividing, right? And I classified the problems we did as the easy dividing. Eli, just stick it back there. I don't have a slot for you quite yet. On my list of things to do is to redo the cards. I just haven't gotten it done yet. Okay. So, the top problems I classified as, they were the easier type of division, right? Because before we ever got started, we were able to divide that fraction, and it was no longer a fraction. And then you were just simplifying a radical. So my number one suggestion, anytime you see a fraction, check and see if it can divide out a fraction form, or at least simplify some stuff. Okay? Now, the ones we're going to look at down here, if you look down there, they don't simplify. They might simplify some, but they're not going to simplify out of a fraction form. And so we have to talk about the idea of rationalizing. There's a basic principle that roots are not to be left in denominators. So we always talk about square roots not being left in the denominators. To eliminate the roots in the denominator, we use the process of rationalizing the denominator. So before we go down to example A and B, I want to just kind of talk about this. And the example I'm going to give to you to just show the idea is if we have the fraction 1 over the square root of 2. It doesn't really simplify anymore, but I can't leave it like this because I can't leave a radical in the denominator. What do I do to this fraction to get that radical out of the denominator? Do you remember? You remember, Keith?
Well, I was going to guess.
Yeah. Okay. How do you get a radical 2 to not become a radical? You times it by itself in square root world. Okay? Because if it's a square root, you need 2 of something to make it a perfect square. And that's our goal there. So, we would multiply that denominator by square root of 2. Now, we're in fraction world. So, what do we have to do? Whatever you do to the denominator, you do to the top. Because when we're multiplying by square root of 2 over square root of 2, we're really just multiplying by 1. On top, what is 1 times the square root of 2? 1 square root of 2, which can just be written as square root of 2. Denominator. What is square root of 2 times square root of 2?
Square root of 4.
Okay, I heard multiple right answers. I'm going to go the slightly long way. Square root of 2 times square root of 2 is 4, yes? However, what should we continue to say? That is just a 2. So, square root of 2 over a regular 2. That would be your final answer there. Okay. Now, keep in mind, I didn't simplify that 2 over 2 because 1, 2 is in the radical, 1, 2 is not. If they're both in the radical or both out of the radical, we could talk simplifying. But if one's in, one's out, you're stuck right there. Now, that was the idea of a square root. Let me slightly change this problem. What if this had been 1 over the cube root of 2? I still can't leave a radical in the denominator.
Be multiplied by square root and cube root.
So if I just multiply by cube root of 2, I'm going to have cube root of 2 times 2, which is cube root of 4. Is cube root of 4 a perfect cube? No. With a square root, we need 2 to make a perfect square. With a cube root, we need 3. So we're not multiplying. If we have a single 2 here, how many more 2's do I need to make it a perfect cube? 2 more 2's. Okay? And so you can write it several different ways. What if I say it's multiplying by the cube root of 2 squared? Because how many 2's do I have now? 1, 2, 3. Okay? Which, could you also write that as 4 if you prefer? By all means. If you'd rather write that you multiplied by the cube root of 4, that's fine. Now, of course, whatever we do to the denominator, I'm doing to the numerator.
Pardon the interruption. I need Mallory Herring to please report to study hall. Mallory Herring, please report to study hall.
In the numerator, what is 1 times the cube root of 2 squared? Cube root of 2 squared, which what is 2 squared? 4. So we can go ahead and say that that is the cube root of 4. In the denominator, what is the cube root of 2 times the cube root of 2 squared? Cube root of 8? You could say the cube root of 2 cubed if you want. You could also go ahead and go to the next step if you really wanted to and say it's just 2. For the notes, I'm putting down cube root of 8, but if you went ahead and made that jump to just a regular 2, that's fine. As we simplify this up and finish this up, what is the cube root of 8? So we just talked about 2. What is the cube root of 4? Some decimal, so I'm going to write cube root of 4. And again, I'm stopping there. I'm not dividing that 4 in 2 because one's in a radical, one's not. Okay, so that process should sound a little familiar. That's rationalizing a denominator. Let's go and look at this with slightly more difficult problems, though. Now, you will notice officially these are both listed as cubes down here. I'm changing this first one. Forget that cube root. We're going to instead work with this as a square root. Okay? Okay. First thing I would check, kind of like the fractions up above. Can this fraction reduce? And as you look at it, 5/12, does 5/12 reduce? No. There's an x squared on top. Are there any x's in the denominator that would reduce with it? No. Y's and z's on bottom, not on top. Okay, so I would always check that first. Even if there's just small bits that can simplify there, I would do that. The other thing I would check before we go into rationalization mode, are there any perfect squares that we could go ahead and pull out of the radical to make this problem a little easier? Okay, there's a y squared and x squared, which I'm going to say let's go ahead and pull those out. What if I would say there's one other perfect square in there? Yeah. What do we know about 12? 12 is 4 times 3. In other words, 12 is divisible by 4, and that's a perfect square. So, I'm going to write this out. Just kind of break it up. 5 is just going to stay 5 when we take out square roots here in a moment. X squared will be able to take that square root. Like yesterday, can you break 12 up? Right? Yeah, because as you start looking, 12 divides by 4. And so I'm going to be able to do 4 times 3. Y squared I'll be able to take the square root of, and z will just have to stay. My goal there really was just get you to break the 12 up. That's what I was doing on that problem. Okay, so I'm going to think of this as a fraction here. In the numerator, what do you know about the square root of 5? Multiplying wise?
Yeah.
Okay. Square root of 5 is just going to stay 5. So that's going to stay in the radical. Square root of x squared. I made that too big. Oh well. What is the square root of x squared? X, because what do we do, guys? It's 2 divided by 2, right? 2 divided by 2 makes it x to the first. Where do I put that x to the first? Out front. So on top, I have x times the square root of 5. Same thing in the denominator. I made this fraction bar way too big, but that's all right. Square root of 4. Can I take the square root of 4? It's 2, so that 2 is out front. Square root of 3? I can't do it, so it stays under the radical. Square root of y squared. 2 divided by 2 again makes it y to the first out front. Square root of z stays in the radical. And because I don't want my z's and 2's to be confused, that's why I put the bar on the z. Okay, if you have your way that you write them so you know what's what, that's fine. But okay, I have simplified all I possibly can. Can I leave this as a final answer? No, because I have a radical in the denominator. So what's my radical in the denominator that needs to go? Square root of 3z, which is better than having this whole thing in the denominator. That's how we've made it better. So how do we get rid of a square root of 3z? If it's a square root, you need one of it. You have to have 2 of it, so you multiply by 1 more of it. So square root of 3z. What I do to the denominator, we do to the numerator. So I'm multiplying numerator and denominator by square root of 3z. Okay, numerator. I have an x outside, and then what's radical 5, or square root of 5, times square root of 3z? Under the radical, you can multiply them as long as they're square roots, so square root of 15z. So we have x times the square root of 15z. Denominator. I already have a 2y outside. What is the square root of 3z times the square root of 3z?
9z squared, so then it goes to 3z.
Okay, so if you want to go ahead and write just a plain 3z at this point, and you're okay with that, do so. Okay, for the learning process today, the other option is to go ahead and write 3z times 3z. I heard multiple people tell me that that is 9z squared. Now, if you're saying 9z squared, it's still under a radical. So can you take that radical if you didn't already? Yeah, the square root of 9z squared is 3z, which it should be. So, I have x, square root of 15z on top. I have 2y on bottom, and now times 3z. What is 2y times 3z? 2 times 3 is 6, so 6yz. So I am at the point of having x square root of 15z over 6yz. And I get some of you have combined these steps along the way. I get that. Now, we have to decide, are we done? There's a couple of things I want you to consider. First of all, are there any perfect squares remaining in the radical? 15, it's 3 times 5. I can't do any square roots there. Z is just z to the first. I can't do any square roots there. So I feel confident there. The other thing you need to check, because this will happen some, does your fraction reduce? Obviously, the radical is stuck as a radical because there's no other radical. But if any of this outside stuff reduces, you would need to reduce it. I have an x on top. Do I have any x's on bottom?
No.
No. 6yz, if there's anything out front that would reduce with that, we would need to do that. Okay, in this case, am I done?
Yes.
We're done. But those are questions you need to be asking yourself, because you will see some that will need to reduce. Okay. One more. Now, this one I'm leaving as cube roots to work with it. Okay. And honestly, I think most of your homework is square roots when you're rationalizing. So that's, makes it a little bit better, but it's still good to talk about cube roots here. So, cube root of 7x over cube root of 5y squared. Does anything simplify before I get started? Are there any perfect cubes there? 7x, 5, y squared. Okay, nothing I can take a cube root of. Nothing that reduces. 7 over 5 doesn't reduce. There's no x and y that reduce. So, how do I rationalize? What do I need to multiply by to get that radical out of the denominator? I'm going a little bit too far, but I see where you're going with this. Let me ask this a different way, because we could do that, but I want to try and make it a little bit easier. Okay, think about the 5 right now. What does it take to make 5 a perfect cube? We have 1 5 right now. So if we do one more 5, is that a perfect cube? 5 times 5? No, not a perfect cube. How many 5s do we need to make a perfect cube? 3. I currently have how many 5s? 1. So the first thing I'm going to do is I'm going to do a 5 squared, or 25 if you prefer. Because if I multiply by 5 squared, that gives me a total of 3 5s. Now, okay, Jace was wanting to do y squared and y squared twice. We can do that. It just means a little bit more work later on, in my opinion. Think about it this way. How many y's do I currently have? 2. How many y's does it take to make that a perfect cube? 1 more. Do you see where I'm going with that? As opposed to just multiplying by itself, which I get it. I totally get it. It makes sense. To me, it's a little easier if we say, okay, there's already 2 of something. Now I just need 1 more to make 3. So I'm going to multiply by just a single y. What I do on the bottom, we do on top. So square root of 5 squared y, top and bottom. Okay. Multiply for me. On top, cube root times cube root, there's nothing outside. 7 times 5 squared is what? 7 times 25 is 175, and then what variables do I have? X, Y. Denominator. If you want, you can think of it like this. It's 5 times 5 squared, which is how many 5s? How about if I say 5 to the third? Or if you prefer, you can say 125. How many y's do I have? Y squared times y makes it y to the third. Here's what's easy to know, guys. When you have the cube root of a cube, what happens when you take the cube root of a cube? You get the base. You cancel each other out. It's the same thing as what happens when you take the square root of a square. They essentially cancel each other out. So my denominator is going to be what? 5y. Now, the question about the numerator is, did I create any perfect cubes there that I need to simplify? X and Y, I'm okay. 175. Is 175 a perfect cube? Does it divide by any perfect cubes? Does it divide by 125, 64, 27, 8? And you can check all those on your calculator, and they're all going to give you decimals. So, what stays on top? Cube root, 175, x, y. Can I simplify anything? Okay. We just checked that cube root doesn't simplify. Can I simplify 175 and 5?
No.
No, because one's in a radical, one's out of a radical. So we're done right there. Okay. If you haven't started, your homework is in Math Excel, Lesson 6-2. It'll be due Monday.